Welcome back, friends, to Derivability. If you're new, thanks for stopping in. Okay, today we're going to take a look at sum and difference identities for sine and cosine for some trigonometry. Okay, if you're taking trigonometry, depending on what level, this might be of interest to you. Honestly, if you're taking calculus, maybe you need just a little bit of refresher on some of these sine and cosine identities. Or honestly, maybe you're taking a higher level math or physics engineering class. Never a bad idea to take another look at these. On a previous video, I proved the cosine difference identity. Okay, you can check that one out if you want to see how that one can be derived. Okay, but that's where we're going to start, cosine difference identity. Okay, a little reminder, where you are expecting to see an equal sign, you might be seeing three lines. Okay, so that three lines symbol, sometimes we mean to say is for something to be identical to something else. Okay, and what that means is that no matter what the values of the variables are, you're always going to get the same thing on both sides. Okay, it's a little bit stronger statement than merely an equal sign. Okay, all right, so what we're going to do is generate a cosine sum identity by taking angle phi in this formula and setting it equal to like negative something. So I'll just choose a Greek letter, so negative alpha. Okay, so what we get here is cosine of theta subtract negative alpha should be identical to cosine theta, cosine of negative alpha, plus sine theta, sine of negative alpha. Okay, now what we are finding on the left side is that we get a theta plus alpha inside the cosine. Okay, then how do we resolve these negatives inside of these trig functions? Well, you remember that cosine is an even function, and sine is an example of an odd function. Okay, and I also have video about that if you want to check that out. Okay, what we can do now is simply write cosine theta, cosine alpha. Now the negative on the sine alpha, sine negative alpha here, we can just bring that outside. Okay, so this becomes minus sine theta, sine alpha. Okay, and this is what we can call the cosine sum identity. Okay. All right, now you can use letters theta and alpha, as I have done here at the very end. You can kind of swap your alpha back to phi and use the same letters that we did in our original cosine difference identity up here to start with. It's really all up to you. Okay, if I were writing these down like on a note card or like a master sheet or something like that, I'd probably go back and use the same letters each time, theta phi, for instance. Okay, it shouldn't really matter. All right, but I'm going to leave that there and let you handle the notation if you want to change that for your notes. Okay. All right, next, what I intend to do for us here is to generate some sine identities. Okay, so let's start with our cosine difference identity here. And now let us make the replacement theta equals pi over 2 minus some Greek letter. Doesn't matter what it is. Maybe I'll just choose beta in this case. Okay, so in that case we get cosine, now in place of theta, pi over 2 minus beta. And then there's still that minus phi. Okay, right hand side cosine pi over 2 minus beta cosine phi plus sine pi over 2 minus beta sine phi. Okay, now we are going to use cofunction identities. That was kind of the way this is being engineered from the beginning. So if I have cosine of pi over 2 minus, I'll just pick some other angle name, maybe the Greek letter delta. Okay, that's always going to be the sine of delta. And then likewise, the sine of pi over 2 minus delta, always going to be the cosine of delta. And of course, delta can be anything. It can be a beta, it can be an alpha, whatever. All right, so I'm going to use these cofunction identities in these two positions. Okay, also notice that on the left-hand side, I can factor a negative from the beta and phi terms like that. So the argument of that cosine on the left becomes pi over 2 minus the grouping beta plus phi. Okay, and now there are three places that I can use a cofunction identity. Okay, on the left side, I have a cosine of pi over 2 minus something, and using this cofunction identity, that becomes the sine of the something, beta plus phi in this case. Okay, the underlined cosine pi over 2 minus beta, that just becomes the sine of beta. Then we still have the cosine of phi still there, plus. And then the underlined sine pi over 2 minus beta, okay, using our cofunction, that's cosine of beta, and then we still have sine phi remaining in that position. And before you know it, we now have something that we can call a sine sum identity. Okay, all right, so we've got three here. There's the one we started with, the cosine difference identity. Okay, the cosine sum, and then the sine sum. Okay, what we really need now is the sine difference identity. Okay, so let's create some clean space here, and then we'll get back to it. All right, so let's pick back up with the last one we finished with, the sine sum identity. Okay, I wrote it back up at the top here. Now, I changed the letters, which is okay. Just make sure you do it in a consistent way. So just double check if you want to rewind the video for a minute that I replaced some letters in a consistent way. Still have the same identity. Okay, so now I'm going to let phi equal negative something, maybe a Greek letter negative epsilon. Okay, so if I do that on both sides, left side I have sine of theta plus negative epsilon. Should be identical to the sine of theta cosine of negative epsilon plus the cosine of theta times the sine of negative epsilon. Okay. All right. Now on the left-hand side, we're just going to write that as theta minus phi on the inside. Sorry, theta minus epsilon. On the right-hand side, once again, you're probably recognizing we can use some even and odd identities. Remember, cosine is an even function, sine is an odd function. Okay, so for even functions, this negative just goes away. And for odd functions, the negative can come out front. All right, so what does that mean right here? We have sine theta cosine epsilon minus cosine theta sine epsilon. Okay, and there we go. This is our sine difference identity. Okay. All right, so we've got all 4 of them. One of them is from a previous video, and 3 more right now. Okay, so there you go. Now, you might be asking, what about like tangent identities? Well, good question. That is a topic for another video. Okay, I hope you'll find that on the channel when that comes out. Thanks for stopping by. If you haven't subscribed yet, I'd love if you would do that. Share this channel with your friends, classmates, teachers maybe, and hope to see you in our next video.